How does interrupt handling utilize the interrupt vector table? Imagine your microcontroller as a busy city with many roads and traffic signals. When a sudden event happens, like a car breaking down or a fire alarm ringing, the city needs to respond quickly. That's where interrupt handling comes in. It's like having a system that instantly knows where to send help. But how does it know exactly where to go? That's where the interrupt vector table comes into play. Think of it as a detailed map that guides the microcontroller to the right emergency route. The interrupt vector table is a special section of memory that holds the addresses of all the interrupt service routines, or ISRs. Each ISR is a small program designed to handle a specific event, like a timer overflow or an external signal. When an interrupt occurs, the microcontroller doesn't waste time guessing what to do. Instead, it looks up the interrupt number in the vector table. This number acts like an index, pointing directly to the location of the ISR in memory. Once the microcontroller finds the correct address in the table, it loads that address into the program counter. The program counter is like a GPS that tells the microcontroller what instruction to execute next. By loading the ISR address, the microcontroller jumps straight to the routine that handles the event. This process happens very fast, allowing the system to respond immediately without wasting time on unnecessary checks. The location of the interrupt vector table is usually fixed in memory, making it easy for the processor to access. In some systems, the starting point of the table can be moved using special registers, giving designers more flexibility. There are different ways the processor uses the table to find the ISR address. In some microcontrollers, it directly loads the address stored at a fixed position in the table. In others, it fetches the address indirectly using the interrupt number as a pointer. This setup is essential for managing hardware signals like timer overflows, external pin changes, or communication events. By mapping each interrupt source to a specific routine, the interrupt vector table ensures the system reacts quickly and correctly. It also helps in prioritizing interrupts, so more important events get handled first. This method keeps the system running smoothly, even when multiple events happen at once. In real-world applications, this means microcontrollers can handle many tasks efficiently without complex polling loops. They can also operate in low-power modes, waking up only when needed. The interrupt vector table is a simple yet powerful tool that keeps embedded systems responsive and reliable. It organizes how the microcontroller responds to the world outside, making sure every event gets the attention it needs, right when it happens.